Okay, cool. So I'm very happy to welcome Jeff Huang from Brown University today, where he's an assistant professor and has his own research lab. And I was always very impressed by Jeff's work because he builds these super clever solutions for personalized user interfaces based on actual user behavior. That's something I'm also personally very interested in from a different perspective. So I'm very glad to have Jeff here today, and let's give him a warm welcome.
Thanks for the really nice introduction. Hi everyone, so glad to be here. Thanks for coming out to my talk. What I want to talk to you about today, I want to show you is some of the work that we're doing in my research group at Brown, and to tell you a bit of a story about how we've been using some pretty easy to collect data to invent some systems that I think would have not been possible with this kind of behavior data. And I want to start by saying the research that I'm talking about, that I've been doing, actually started out of almost like pure randomness. There's no starting reason behind it. Actually, I'll tell you a story about how I got started. So it was actually when I interviewed for an internship as a research internship at Microsoft in the Bing UX group. So it's with a manager who was in charge of all of the user experience for the search page. And he came out, he said like, hey, for the interview, come in with a couple of ideas of things you want to do. And so I was like, oh, okay. And so I like pulled up Bing, and it looks like this. And so I pulled up the search engine, and I just like stared at it for about an hour and trying to come up with like ideas of things to make it better. I came up with a couple ideas. One was clearly a bad idea. And I'll tell you what it was. It was I was noticing at that time that monitors and like screens were getting larger and larger. And I was like, wouldn't it be cool if instead of one column of search results, we just had like multiple columns of search results, like results all over the page. That would be crazy. And in retrospect, now I know it's a bad idea. And I know it's bad because there's a startup that did it. It was called Cool, like C-U-I-L, and they went bankrupt. So that was clearly a bad idea. Glad I did not do that. The other idea turned out to be kind of like interesting and something that nobody had been doing at that time, which is, hey, I noticed when we were actually using this search results page, so here I'm searching for Boston chicken farms, because I'm interested in, I raise chickens in my backyard, so I was like, what kind of farms are nearby? But I noticed when I'm searching for this, I'm actually moving my mouse cursor around. I'm doing things besides just looking at the page, right? I'll sometimes hover over things and not click on some text. I'll scroll up and down on the screen, so I'll have kind of the scroll bar, like look down, come back up. You know, I'll kind of examine the page in a little bit more detail. And so the idea I had, the seed of this idea was that the cursor and scrolling behaviors can actually be captured remotely. So just using JavaScript without kind of anything to install, it can be captured on anyone's browser, and actually we can maybe do something cool with it. So that was the idea, and I actually went and implemented this at Microsoft. So we ended up getting a few things out of this. The first time I was there, we just looked at in general how are people searching using these cursor interactions, just kind of more descriptive stuff of like what they look at, what they examine, or what they hover over before and after they click on different search results. After that, we were like, hey, can we do something even better and maybe see what are people actually looking at on the search page? That's kind of the gold standard, right? If we can actually figure out what people are staring at without an eye tracker, that'd be really cool. So we had some work on that. And then the next thing is kind of the holy grail for information retrieval, which is, can we actually do better search result relevance for the user based on things they're doing on the page? So based on how they're moving their mouse, what they're hovering over, what they scroll up to see, can we use that to make the search results better for them in the future? So re-rank the search results with better scores. And then lastly, we noticed that different people actually use their cursor in different ways. And so what are the different types of people? And can we kind of use that to figure out if we should kind of adopt the system for different people in a different approach? So these are kind of the projects I had done, and they were all in collaboration at Microsoft. And then afterwards, I was like, this is pretty cool. But I felt like some of this work was, it was more like a kind of feature or doing some parameters for like the search engine. But it wasn't doing something that I really wanted to do, was kind of invent new things that people would use and they could kind of visibly see and that they were using what I was doing. So afterwards, after my PhD, when I joined Brown, I thought to myself, what is some work that I really wanted to do? Because I feel like sometimes if you don't have some like guiding principles of what you want to do, then the default is just continuing things you've been doing in the past. It's very easy to kind of say like, oh, I'm interested in doing like whatever I did before, and kind of write that next paper. So I spent some time to think about what I really want to do. And kind of, so I had two insights that kind of become my guiding principles. I had spent a lot of time looking at behavior data. I looked at data at Yahoo, Bing, and Google about how people are searching and using their websites. And one idea I had back then is that everyone is just so different, and that we can make things perform better when we personalize it, tailor it to specific people. So everyone can have their kind of own interface, their own system. And the other thing was that there's a lot of this kind of like passively recorded data out there, like easy to capture, like user interactions online, or mobile sensing data, location data. All of this kind of data is like almost like free to have, and it'd be cool to, it's a huge opportunity, I think, to make something that people actually would use out of this data. So that's kind of one principle. The other was, I really believe in kind of making products that people actually use. So I wanted to make products that, and the way I define it is, I think a lot of people talk about systems, but the way I think of it is actually, systems are something that I build. They could be prototypes, and that's the system. But a product, in my mind, takes it to the next level, and it's something that I could just put out there, and people can use without us making them use it. So I think in HCI we think a lot about evaluation, right? We all think about how are people going to evaluate the work, and so in my mind, one evaluation metric that I use is if people are going to be using my work without me making them use it, then I'm successful. If people are using what I do to kind of change something that they're doing, and it's like completely voluntary, like I just put something out there and they use it, then that makes me feel successful. So those are kind of the principles I had in my work. So then afterwards, I kind of went back and thought about my own work and how I could apply these to what I was doing. So I'm going to highlight in this talk 4 products that kind of embody some of these ideas. The first was back at this kind of original idea of cursor, using the mouse cursor movements. And originally I thought, there's a couple of benefits to using mouse cursor movements. You can scale them easily, that everyone can track cursor movements on anyone's machine if you own the website, and it's kind of in a natural setting without disrupting the user. But I think I was thinking about it in a very limited way. So the way I changed what I was thinking about is, instead of using the cursor as like a way to figure out where people are looking, can we actually make eye tracking better and make it possible for anyone to do eye tracking on their own machines? So the way that eye tracking works now is, how many people have actually used like an eye tracker before? I'm just curious. So you get this like kind of really expensive system. It costs about like $28,000 or $40,000, and there's specialized hardware that shine an infrared light into your eyes, and there's a camera that captures the reflection from your cornea to determine where you're looking on the screen. But I've noticed like, hey, we have webcams actually, and at that time webcams were getting better. I think the MacBook at that time would just introduce the like FaceTime HD, whatever they call it, camera, basically a 720p camera. And I said, instead of just using the mouse cursor as kind of a proxy of where people are looking, can we actually do eye tracking that uses the camera, but also the mouse cursor interactions to make it better? So that's going to be what the first project I'll talk about, which is called Webgazer. And it's about changing how we do eye tracking from kind of an in-lab, like infrared eye tracker, to something that anyone can do on any laptop at any time. So if you look at an eye, this is kind of a blown up image of someone's eye. You'll notice that when you're looking at different parts of the screen, how your pupil looks relative to the rest of the eye changes, right? So if you're looking at the top right of your screen, the pupil is kind of closer to the top right of relative to the location of your eye, right? And even like kind of the shape of the pupil is slightly different. So there's kind of changes depending on where you're looking. And so this is the first trick that I had, which is, I noticed, so if you think of when people click on something on a screen, what do you think they do right before they click on something? They look at it, right? So imagine trying to click on something without looking at it. It's pretty hard, right? Like there's a button on the screen, you can't look at it, but you have to click on it. It's really hard to do. So everyone has to look at, or in general, most people have to look at something before they click on it. And so the first trick that we had is, well, we can actually capture a picture of what your eye looks like right before you click on something. And then we can have a picture of an eye and that position on the screen, and we know you looked at that spot, and we know what your eye looked at right before it when you were looking there. So we can kind of turn your eye into a set of features and a vector of features, and then we can map them to positions on the screen. And the idea is, if you're using a website, the longer you use a website, the more times you click on the page, you interact with it, right? And so these kind of clicks can kind of create more and more mappings between kind of what your eye looks like and features from your eye to positions on the screen. So you can build that up over time. So that's the first trick. The second trick is, we notice that everyone is a little bit different in when they click on something after they look at it. So some people are pretty quick. They'll look at something and then immediately click on it about 200 milliseconds later. And some people take maybe up to like 800 milliseconds or 700 milliseconds. So they can take a little bit longer. And figuring out this kind of gap is really important because if we're trying to create the mapping between the eye and positions on the screen. So the second trick is trying to figure out what is this kind of gap for each person. So personalizing a model so that we have this parameter that we can adjust depending on how you are as a person when depending on how you look and then click on something. So that's the second trick that we had. And the third trick was, even when you're not clicking on something, I told you before that about mouse cursor movements, how sometimes they are actually related to where you're looking on the screen, sometimes they're not. So we're actually going to just take the most recent movements. When you're using your cursor to do something, we take those and weight them a little bit less than a click, but we still use them as part of the model to figure out where you're looking on the screen. So this is kind of another mapping that we're using. It's not as good as a click, but it's still kind of useful. So we have these three tricks that kind of are put together: the clicks, the delay, and then the mouse cursor activity. And combined together, we made something called Webgazer. It's made of these modular components, so just pieces of things that we put together that are based on some of these tricks and some of these libraries that we use. It's compatible with 3 kind of off-the-shelf libraries for detecting just where your eye is in the image. So we've made it work with kind of 3 libraries out there, and then we've tried different regression models. It turns out ridge regression works really well because when you start doing eye tracking, when someone starts using a web page, they haven't done much. So there's very few parameters, or there's very little training data. And so ridge regression lets you kind of train without that much training data. And it works fairly well for when you have a large dimensional space. And Webgazer is a pure JavaScript library, so it works just on the web. There's nothing to install. It's scalable, so like any website, you can put on any website Webgazer, and then you can actually track where people are looking if they consent to it. So, and the other kind of feature, just because we're kind of creating these mappings of eye and positions on the screen over time, is it continuously trains. So it always keeps learning from what you're doing and figures out where you're looking. So let's see what it looks like. This is Alexandra, my PhD student who led this project.
We present Webgazer text and online eye tracking library.
Let me just mute this and I'll just talk about it. So this is Alexandra searching for some images, and the red dot here is kind of where the prediction of where she's looking at on the screen. So you can see she's like looking across different images. It's a little bit jumpy because we don't do any kind of smoothing on it, just because we want like the instant feedback of where you're looking, but this could be something you could add in. But you notice that so when she scrolls, it actually kind of changes, it kind of goes with the page, and you can see kind of about where she's looking on the page, right? You can't see exactly maybe the word, but about the region sometimes works. This is Gmail, so this is actually a case where you actually have to click to use the interface. It's hard to use Gmail without clicking on anything. So actually, it actually can train a model better. So the more you kind of use Gmail, the more training data it's getting and learning about where it might predict where you're looking. So that's kind of what it looks like. So the red dot is her actual where she's looking, and her using this email interface. So right now it's just we've released online. It's just 2 lines of code to put on any website, so you can do it on anything that you own. And the other thing I want to talk about is how well it works, right? So the accuracy is really important. This is Webgazer is compared to the accuracy of Webgazer and a Tobii IX, which is just a consumer eye tracker, I guess. It's a cheaper Tobii. And the green line here is the Tobii eye tracker, and the blue line is Webgazer. And the top chart is the x-coordinate, how well they correspond to the x-axis, and the bottom chart is for the y-coordinate. So this is a task where we had somebody kind of go down on a screen from like top to bottom to like, I think, answer a little quiz that we made. So it was just for fun. We had them kind of go down from top to bottom on different columns. And you can see here that the x-axis doesn't change for the first while because they're in the first column. Then it jumps to the second column and the next column after that. So you can see these jumps. You can see that the Webgazer and the Tobii are somewhat correlated. There's maybe some more variation in Webgazer. It's more jumpy, right? It doesn't have an infrared camera, and it's using it just based on your eye tracker. But then it kind of continues this mapping over a period of time. This is the person kind of looking up and down the page. So on the y-coordinate, they're looking from 0, which is the top, to the bottom. So they're just kind of looking down, and then Webgazer actually tracks the Tobii IX as you're going. So that's kind of about how it works. In general, it works. It's about like 1.5 inches from where you're actually looking on the screen. So it works okay for detecting things in a region, but probably not for the exact word where you're looking. It's never going to be as good as an infrared eye tracker. But we actually want to see, like, hey, is this actually good for some things? So we what we did is we took some classic information retrieval that actually used an eye tracker in the lab, and this is including Kushal and Huang, much of the earlier papers about where people are looking on the screen when they're using search, and some later papers, one by Busher et al. About how people look at ads, and one by in Eugene Eisenstein's lab about what results we're looking using their own tool. And so we kind of compared what the results would have gone if they used Webgazer versus their original eye tracker system. So we actually just took these images straight from their paper, and we tried to make charts that sort of mimic the look of it. But you can see in general that the results from Webgazer are somewhat similar. The shape of them is similar, so you would actually get kind of qualitatively similar findings. Some of the numbers are a little bit different, like here. This is a chart about how long people spend looking at different search results and when they arrived at that search result. And you can see here that the number is about 2.2 here in terms of how long, 2 seconds that they spent looking at the first result versus 1.7 or 8 seconds in Webgazer. But it might be just because since 2007 people have kind of changed their search behavior, or that things are just a little bit different than back then, the UI and stuff. So, but in general, you would have gotten about the same shape of the results as the classic work. That's what we found with several of these studies. The cool thing is, instead of running a kind of multiple week lab study, we were able to get these results in just like 1 day with hundreds of people in very little time. So we could just throw the experiment online and just scale it by the number of people to have them actually just from their own home do the task, and we get similar results. So I thought that was really cool. It's also, like I mentioned before, I think it's really important that we get our stuff out there. So we released our software on GitHub. We have documentation, videos, and demos and stuff. And so we actually noticed that people were actually using it. So we had about 170 forks, which is just like people kind of building off the work so far. This one is kind of cool. This is somebody sent us this. It's a globe that rotates based on where you're looking at on it. So if you were, and my geography is really bad. This is like rotate. If you're looking at Greenland, I think that's the white thing, right? So if you're looking at Greenland, then it rotates to be the center of the map. So you can focus on one particular country, and then it kind of zooms it into your view, right? So you can rotate around the globe like that, or just focus on one piece of it, and it kind of adapts based on where you're looking. This other one is a demo from Columbia University. So this one is he made an app for his Tesla car, and the idea is it's kind of dangerous to use a touchscreen while you're driving, obviously. So what if you could just track where you're looking on the screen? So there's a screen that kind of tells you how far ahead the gas or the electrical charging stations are, which is really important in an electric car, and how much further you can go and how low you'll be when you get there. So that way you can kind of plan your trip ahead, and by just looking at the screen, figure out, is this safe for me to drive there, right? And you'll notice it's jumpy. It's not like super accurate, but you can kind of, you can tell when he's looking kind of near the bottom of the route versus the top of the route, right? So it is still helpful in figuring out how far you can drive down there. So that was Webgazer. I want to pause for a second to see if there's any questions. Yeah.
Get people to volunteer to have their webcams turned on while browsing the web.
Yeah, that's a great question. So it's like, why would someone, if I go to a website, agree to let it see where I'm looking? So there's a couple of things I want to say. So one is our library just takes the video image and actually does all the processing on client side, does all the training on client side, and just sends the coordinates of where you're looking to the website. So that way it's like a little bit more privacy preserving because it doesn't send kind of like your room to them, right? The other thing is usually these systems only work if there's a direct benefit to the user. So I can imagine things like you go to the New York Times, instead of having to pay to access an article, maybe you agree to let them see what you're reading for a few minutes as an exchange. So they can see what articles people are reading and how long it takes you to read an article, and you can get the access to that article for free. Yeah?
Two questions. On the Tesla app, the idea is instead of having to touch the screen, it tracks my eye?
Yeah, so instead of having the touchscreen to pop up these kind of these info boxes about how far you can still drive with the electricity, you can just look at that area.
Okay, but the problem with the touch screens, the problem with the screens of the Tesla is taking my eyes off the road.
Yeah. Oh yeah, that's it's still probably like not an ideal situation.
Okay, just
yeah.
want to see which problem we're solving.
Right. Yeah. No, I mean we didn't make this. This is a different, separate
I
project.
understand, this wasn't your idea.
Yeah.
And in general, at least in the past, the previous research on gaze-based interfaces has been often frustrating because your eyes are not a cursor. And we're just, first of all, we're not used to trying to control things with our eyes. And second, given the way your gaze jumps around, it's often not a very good way of saying what I want to do. So are you dealing with that kind of thing?
Right. So there's a couple issues. One is like the live mic problem, which is like your eyes are always on. So no matter where you're looking, it's tracking you and thinks that you want to interact with the screen that way. The other is that, like you said, it's really jumpy. Actually, a lot of people don't even realize where they're looking, or like, you know, because a lot of times when you look at the screen, you don't actually just focus on it. You kind of like jump around a little bit, right? Even probably maybe when you're watching here, you kind of just like randomly look at that, you know, speaker or the ceiling or something, right? So you just bounce a little bit. So we haven't solved that problem at all. So what we're trying to do is actually do kind of the most accurate eye tracking piece itself, and then there could be maybe a processing step afterwards to maybe smooth out the interaction, or like try to just use fixations with it, or someone could do something where you use blink as an interaction. So I think there's kind of a next step to this, and this is just the beginning. Absolutely. Yeah.
Could you might be talking a little bit more about resolution later on, but it sounds like you can't get to word level.
Yeah, I don't think webcam eye tracking can do word level. I mean, especially one that's on JavaScript completely online. So that's been hard. I think, well, one thing I'll mention is we are actually trying to get improved accuracy in a very systematic way. So we have created a data set of about 50 videos where we actually have the video. We have the Tobii eye tracker to say where you were actually looking on the screen. So we got a commercial one that did that. And then also kind of ground truth data. We actually told people like, look here, look here, look here. So we actually have the video interactions, the eye tracking data, and the screen capture and everything. So if someone wanted to do some kind of like really fancy computer vision deep learning, then let me know and we'll share and collaborate, because I think that's kind of the next piece, so we can become more accurate later on. But it was hard. The hard part is actually, because it's a webcam and it's a stream, if we improve something by, let's say, like 3%, like we think we improved it by 3%, you actually can't prove it, because the next time someone sits down, the lighting is different, they're doing something different, so it's always just a stream. So we decided, hey, we're going to make a whole bunch of these videos of people doing tasks and like looking at certain places, and now we can actually kind of do the standard machine learning thing of like optimizing this one piece of data set. Great, thanks for the questions. So I'm going to talk about a small project now. So I'm going to switch between big projects and small projects. This one is based on a similar idea, but to do something totally different. So instead of eye tracking, it's about maintaining data. So this project is called Drafty. And this started actually when we created a data set of, we're really interested in what professors exist in the US and what they got, where they got the degrees and where they went to school and all this stuff, right? So we actually created this kind of interesting data set originally that was crowdsourced in one of my HCI seminars as a kind of a lesson to do crowdsourcing. So we made all the students do their own crowdsourcing. We combined this data set here. And so it was kind of cool because you actually can see, for example, what fields are hot right now based on kind of when someone is hired for that area, or what schools are good for if you want to become faculty later, where people often get their like bachelor's or doctorate. So this kind of data is kind of interesting descriptively. And this data set was useful. We put it out there, and we actually had like quite a few people using it. I think over 100,000 people actually went and viewed the data, and a lot of people emailed us saying like they made really important department decisions based on it, like what areas to hire in, or how they made a case to their provost that their department was a lot smaller than their peers based on their ranking or something like that. Apparently, every department can make a good case based on this data that they should grow. So that was cool to see. But the problem is that the second we collected this data, it was immediately out of date, because people are kind of changing positions and getting hired and changing subfields sometimes. So things change a lot in the data and it becomes out of date like instantly. So how do you actually keep a data set that's always changing up to date? And the initial idea we had is, hey, let's just continue crowdsourcing and let's keep having mechanical Turkers update and review this data. The problem is it actually gets harder and harder the longer you do it, because then first of all, mechanical Turkers don't understand so many academic academia concepts, like what is a postdoc, or what is even like machine learning? Is it the same as machine reading? Even things like the titles of faculty, like they don't understand that a chaired professor is not like a professor that sits in the chair, or that the Amazon professor of machine learning isn't some machine learning professor that works at Amazon. It's just like the that company sponsors that chair. So it becomes really hard for the mechanical Turkers to really verify in data. So the people that we thought would be the best at reviewing the data are actually the people using the data. So these were the computer science community people that actually came in and actually looked at the data. And I think actually David was one of the people that also looked at it and built something on top of it. So like someone like David would actually be really good at helping fix some of this data. And so the idea is, let's just ask people when they're using the data to help fix the data. And the next problem becomes, if we just ask randomly somebody to fix the data, then they might not be really interested. Like if I asked you for, let's see, what's the missing piece of data, where this professor, Ira, where did they get their bachelor's? You probably don't know or don't really care that much, and you would just close the box, right? So it wouldn't be that useful. But then we thought, well, we can actually see what people are doing with the data set, and then maybe we can actually learn a bit about them, build a profile of them. So what we've been doing is tracking what people like scroll to, what they highlight. Like a lot of people will highlight some text and copy and paste to search for that name later. They will sort by a certain column or type in a search query in a subfield. They might just search for human-computer interaction. And then so we can actually start to get clues of like what universities people are interested in, what fields they're interested in, and you can kind of put that together. So for this audience, maybe if I asked you where like Rob Miller got his bachelor's, you might know that, or you might be more interested in at least to find out, right, and then help fill in that data. So we'd say like, these people in this room have searched for things about HCI before, and they've looked at a lot of professors from MIT. They're probably interested in HCI professors from MIT. Let's go and ask them about that. So that was the idea behind this system, Drafty, which we've put out there, and it's been running for about, I think, 8 months now. And we've been doing basically an A/B test. So on one hand, we had people where we collect profiles of, so we build this kind of profile based on your interactions, just very subtly learn about them and sort of ask them to fix things. So we ask them, like, where did this person get their master's? And if there's actually, we actually know some ideas of where they may have gotten their master's and list them. So we can actually ask them to help fix the data. On one hand, we do that. And then there was another group of people where we don't. We just randomly ask them to fix things. We wanted to compare if building these profiles is actually useful. So far, we've been running this lab experiment. It seems like if we ask people to help volunteer to review items that we think they're interested in, right now they're about 2 times more often likely to volunteer to help with the fixing, which is good. But also kind of interesting, we found out they're 3 times more likely to be accurate. So we kind of went and hand-checked some of their edits that they've made, and the people that actually fixed data that we thought they were interested in are way more accurate. So that's a good thing. That's another kind of thing we were able to use using the free interaction data, do something kind of really positive out of it. So that's something we've been running for a while, and the hope now is I'm actually hoping to kind of put some new data sets on it, like a data set of scholarships or fellowships to apply for, which is something that changes every year and also requires kind of like people that don't apply for fellowships don't care, but people that do kind of often create their own spreadsheets. So we can actually have a central database for that kind of stuff. Any questions so far? Okay, so I've talked a little bit about online interactions and different projects that can do eye tracking or maintain data using very subtle clues from people's online interactions. And I want to switch a little bit to what about other sources of behavior data? So one is mobile. So this is another data source of really rich information that you can get about people. And so I want to talk about the next project, which is called Sleep Coacher. And this is a project for changing how we can improve people's sleep. So that's the idea behind this project. I want to start by asking, how many people here actually sleep every day? All right, quite a few of you. Now keep your hands up if you're completely satisfied with your sleep. A lot fewer. Okay. Some people are very healthy sleepers. That's really good to see. But there's a lot of people actually that don't sleep that well. And there's a few ways that people actually try to fix this. So on one hand, there's sleep apps or devices. So the Fitbit does some stuff about sleep tracking. There's a bunch of apps. I don't know if you've heard of apps like Sleep Cycle or see if it's Android UV app. Then there are just apps that basically you put on your bed and it kind of senses stuff and then tells you about how you've been sleeping. The problem with these apps and devices is they just tell you what's been happening, like here's how you slept or when you went to bed, things that are like descriptive, but they generally don't tell you how you can sleep better. They don't say like, do this to sleep better or try this. And the reason is because they don't really know. Everyone is very different, and they don't have sleep clinicians kind of working on this idea of looking at the data and giving recommendations. On the other hand are sleep clinics. So these are actually very specific kind of labs that people with sleep problems actually can go in, and they will get hooked up to a bunch of these sensors, and it's called a polysomnography if you want to go in and get kind of an idea of how well you sleep. And you can do it for just a couple nights because it's kind of expensive to sit in this room. You have to go to bed at a certain time, and then someone actually watches you sleep the entire night. So it's like really intrusive, it's really unnatural, and it's expensive. So you can only do it for a few nights. So we thought, is there a way we can kind of combine the best of both worlds? And then using them, we can actually make recommendations, ideas for people to actually sleep better, but also do it in a scalable way. So first we wanted to see if the sensors on your phone or devices are actually useful. So I had one of my undergraduate students wear all the sleep devices and sensors we could find and put all these phones on their bed at the same time. This is actually her here, right? So you can see she's wearing like the Microsoft Band and the Fitbit and the Jawbone and a bunch of these other things, and got these phones on the bed. And there's also a few more that are not wearable. They are pills that you attach to your pillow. So this student, thanks to her, we were able to get this kind of interesting data where she slept basically a week with all these sensors. And the first thing you'll notice is that these sensors actually do seem to do something. There is some relationship between these devices up here and the one on the bottom, which is the emotion logger. It's a medically validated device. And you can see that the bedtime, they vary in accuracy, but some of them seem to know a little bit about when you went to bed, or like she, I guess, woke up at 7 for something, maybe she went to the bathroom or something like that. And so you can see most of these devices actually figure that out. And the devices also tell you a little bit about how deep you sleep. I don't know if that actually works, because when we actually watch people doing a polysomnography, they would change sleep stages, and all you would see that would change is kind of the brain sensor waves. They didn't change anything else, except for maybe like the eyes fluttered a bit. So there's no movement. So I'm actually really skeptical about these devices tracking kind of the deepness of your sleep. But I think the awakeness is a good sign that the sensors can do something to figure out when you've been sleeping. So that was the first thing we did. Then, so it's better than random. Then we looked at kind of like some of the sleep data, and we worked with our partners. We worked with our partners at Sleep as Android, which is the largest sleep app out there. So their company is called Android, and this is kind of the data that they had. So we've been working with them for a while, and this one's actually a kind of a fun chart. And I, on purpose, didn't label one of these axes. So on the x-axis is the average number of hours slept by those people, and on the y-axis is degrees, but I haven't labeled the y-axis. So my question to you is, what do you think this y-axis is? So there's some kind of variable out there that greatly affects or is correlated with the average number of hours slept. What do you think this is? The clue is it's measured in degrees. The what?
Sleep side.
Okay, like maybe the angle which they're sleeping? That's a good guess, it's not it.
Latitude or longitude?
That's actually right, yeah, latitude. So it's actually the degrees from the equator, which you'd never think of. So the people closest to the equator actually sleep a lot less, like almost an hour less than people kind of further in the poles. Well, not that far up, but like, I don't know what to call it. I'm terrible at geography, as I've mentioned. So everyone sleeps differently, and actually this is something we saw. Like some people are light sleepers, some people are heavy sleepers, some people are like morning owls, some people are night owls because they have different chronotypes. Some people are just need more sleep than others. Yeah, David.
But that presumably varies by time of year, right?
This is just taking all the data. Yeah, so
that's what I'm wondering about. Right? I'm assuming that the long nights people sleep more, but the latitude, but in the long days they can't sleep more. Like,
maybe
they sleep less.
Yeah, so maybe we should track weather and see how it maps with like cloud coverage. Yeah, great idea. But I mean, our main focus was not on this kind of this data. We actually wanted to build a system that actually personalizes sleep recommendations for each person, because we know that everyone sleeps differently. Can we actually do something for each person individually? So the idea is we have this system called Sleep Coacher, and you also put it on your bed, kind of like most sleep apps. It collects data based on the sensing movement and noise in your bed, and then actually it calculates your own metrics, and then it actually does something kind of interesting, which is it makes you run experiments on yourself. So it gives you a recommendation, asks you to try something, and then sees if it works or not, right? Because it's doing this over a long period of time. You can say, hey, try this, and then we can actually see if you did what it expected, right? If the correlation was actually causal, right? Because actually there's the whole mantra of like, correlation is not causation, right? I think that's what it is. And so we actually want to see, is our correlations causal? So we can actually see at the end of the cycle if that's the case. So just to break it down, so we get the sleep sensing data on the left. So the blue here is movement, the green is noise. And then we translate it into this just giant table. This is like part of what it looks like. So we can capture things like how often you woke up in the middle of the night or how long it takes you to fall asleep. If you used alarms, like if you use the snooze button a lot, your sleep rating, which is like when you wake up, a subjective rating, and then a bunch of these other metrics, like is it the weekend, how consistently you went to bed, how noisy it was, hours slept, that kind of stuff. So we actually build this giant correlation table. Then we say, hey, run an experiment. It's like an AB/AB experiment, and we actually see, if you change your sleep, if you change your behavior, does that actually affect the correlated variable as we expect? Here's kind of what it looks like. So this is net. Oops. Messed up. Uh-oh. Okay. So this is what it looks like. She gets a recommendation on how she might sleep better, like, hey, try going to bed at this time. We notice that there's some correlation here. And so this is her fake going to sleep right now. Put the phone on the bed so the sleep sensors are activated. And then at the end of this experiment, then you actually get a message saying, hey, does this actually work or not? Here it is. So based on data for the last 3 weeks, going to bed consistently at 11 has helped you feel 40% more refreshed. So it actually will give you some quantitative data about what actually happened. So I think that's kind of cool. The way it works is we actually we work with sleep clinicians to generate a set of templates. So they look at some patterns in your sleep and then actually tell us a little bit about what messages to send them. So kind of the text is written in collaboration with sleep clinicians. And here's just an example. Like on average, the noise level in your bedroom is blank. So we actually fill this out with your actual data. We notice that when your room is noisy during the night, you tend to wake up more. On average, you wake up blank times per hour. So also real data that we put in. And then for the next n days, listen to light music or white noise and then tag it if you actually did it. So you can actually see if it works or not. So first we want to see, like, is it actually true that people are different from our own data? So it turns out it is. Here's one example where there's 2 people. And in this case, one person, when they went to bed early, their bedtime was earlier, their sleep own rating went up. So it actually was highly correlated with sleep rating when they went to bed early. And this person was completely the opposite. Going to bed later actually made them rate their own sleep higher. So everyone is quite different. Now the thing that we were wondering is this actually going to work? So we actually ran this on a set of students. We had a bunch of, I think 23 or 5 students actually use this for months. And we want to see, are they actually going to improve their sleep in the way we expected, right? Because we tell them to change something, we want to see if it actually is effective. So here's the results. So first I want to say, when we talked about the study, we didn't actually make people follow the recommendations. We said, use this app, it's going to see if it helps you sleep better. So we didn't strongly encourage them to do the recommendations as we should have. We just want to see what happened naturally. And it turns out about 2/3 of the students didn't really follow the recommendations. Like they followed them like less than 2/3 of the time. And we asked them why. We said like, oh, why didn't you actually do any of this stuff? And they'd say, oh, they've got like an important like exam to study for or a really important party to go to. So there's many really good excuses why you can't follow the recommendations. But the people that actually did, so these each dot is one person, is the people that actually followed the recommendations about 2/3 of the time or more, they all, in general, they slept better about 10 to 20% of the time. So they all kind of saw some improvement in the way that we expected. So I think that was a positive result. Maybe the next part is trying to figure out how to get more of these dots over here. Or maybe we don't. Maybe it's like a free country. You can decide if you want bad sleep or not. So, yeah, David.
I've got a friend who studies the placebo effect, so I'm curious about it. Did you try an experiment where you gave people bad recommendations and see if they also sleep better?
Yeah. So we've talked a lot when we designed the study, either like no recommendations, like null, like boring recommendations or bad recommendations versus good recommendations to do like a controlled experiment. The problem is it's pretty hard to recruit a lot of people to do a very long study. There's like a high dropout rate, and it's kind of there's like an ethics problem of like giving people like try to like drink a lot before bed or something. I don't know, like really bad recommendations. So we didn't do that. I think it would have not gone well with the sleep clinicians. But also, it's kind of, imagine like you participate in a study, and the study is like, do nothing for the next like 3 weeks except track your sleep. You'd be a little dissatisfied. So I think that would be the ideal case, but I think for practical reasons, we just did a non-controlled experiment. So, but the next thing we're actually trying to do, yeah.
Yeah, so you do see some improvement on people who have like very low adherence rates. Like, how do you explain that? And then if that's the case, how then do you attribute the improvements you're seeing on the other side to the recommendation?
Yeah, so you're saying like maybe there's a correlation between people that follow recommendations and in general they were likely to sleep better according to the way we thought they would?
Yeah, something like that, right? Because you also see improvements on people with low adherence.
Yeah. So I mean, I think that's the trickiness with a naturalistic kind of study, like that you can't control for all the variables quite perfectly. I like to think because we actually like predicted, we saw this correlation, we predicted they will improve this way, and they actually did, that it's a little bit not just random. But there's always like a case that, there could be something because it's not a, we didn't randomize people into two groups, or one group got recommendations and one didn't. So that's a good point. So any other last questions? Okay. I'll tell you a little bit about something we're doing right now to hopefully address some of these in a little bit. But I want to talk about the last project, which I think is kind of fun. It's called Rewind. And the idea is when you're not sleeping, hopefully you're making memories. And so this project is about changing how we can retrieve our own memories. And the idea is, we can actually maybe personalize a system that helps you recall good memories in the past. And one of my favorite memories is actually me, when I left my job, I was working at Yahoo, and I left my job to drive all the way up to Seattle to do my PhD. And I remember it was like a really good moment because I had sold all my stuff, I packed everything I owned into my Ford Focus, it's just like a sedan, and I was like, that's everything I own. And I was starting a new adventure, so I was just driving up the coastline with all my belongings and like starting a new life, pretty much. And I remember it was like a really cool memory. And then one thing I learned is actually that on Android, or in most Androids, by default, it tracks your location. And one day I just like noticed like, oh, like Google's been figuring out where I've been. So I actually found a map of like kind of this route in the past. And I was like, this is cool, but it's like not that cool because it's just like a map. So what I actually remembered is not this map, but actually something more like this, right? So I remember driving up the highway, there was like wildflowers on the left, there's like a farm on the right, and I could hear the ocean and smell it, and the sounds and everything. Like that was what it was like when I was driving up to go to grad school. So this is what I remembered, and not this map. So I was like, what if we can actually generate something like this from the map? Because the way I got this picture is from just putting together some Google Street View images. So I said, that's like maybe the seed of the idea of how we can kind of automatically replay some parts of the past. So I'll show you a kind of video. We'll rewind here. And I'll just skip here and I'll talk over it. So instead of actually having to capture memories on purpose, which is hard if you're driving up because you're in a car, you don't want to take photos, it actually has your location data. And what if we can just like take images along that path and stitch them together in a nice way to make it seem like you can kind of replay that part of the past, right? So you take a couple images, and just by replaying them together, you can kind of get this kind of like almost a video, like a jumpy video of you going down this path, right? So this is a particular set of locations that someone had before. And the idea is twofold. One is, let's make it interactive, so we can take these images from your locations and then make it so that you can kind of see them and scrub along them. So actually, you would have to see one image, and then when you scrub on your touchpad left and right, you can kind of travel back and forward at times. You can go back and forth in location and time as well. That's one idea. But then the problem is, like these Street View images are not exactly what you saw when you were there, right? Because they're like all, they're sunny and the weather conditions don't match. You might have seen them at night. So the next part is, so we put together a way to actually manipulate the images so it matches what you actually saw in the past a little bit more accurately. So you have the location data, and from that we can get the weather data. It's hosted on it used to be hosted on the NOAA servers before the NOAA stopped doing that this year. And so, but we actually got the data, and so you can actually look up for a specific location, the weather conditions, and we know what time it was. We can figure out what the season was. We can know if it's windy or cloudy and stuff. It's a really rich data set. So we can actually try to recreate some of the conditions from the past. So here's the original image, and we kind of make it look like nighttime here, or like we actually add some precipitation. It actually looks really cool when it's animated, so the rain looks quite nice, or the snow looks nice, and it actually looks like a real snowy day. Here's for seasons, you can actually compensate for kind of the color and the foliage, right? So here's the original one. In the summer, maybe it looks a little bit more like a deeper green, and in the fall, more yellow. The winter one looks kind of bad. It's just hard to make it look winter because you can't make snow on the ground, so the trees just look white. So I don't know what we can do there. But yeah, for most of the cases, we can actually create something that looks a lot more like what you experienced. And same with sound too. So you can actually figure out, was it windy that day? Were you driving or walking? So if you're walking then and it was windy, maybe it should sound like, I'll try to reproduce like, right? It sounds a little bit like that. Whereas if you're driving on like a rainy day, it's like, it sounds a little bit like that. So you can actually recreate the kind of experience of what it was like back then. So kind of put the prototype of this together, and we actually ran a study, wanted to see what people did. So we got this prototype. We actually had people go out during the day, and we tracked their location. And then we kind of let them interact with their own location history this way. So it's kind of remembering a path. This is in Providence. This person just kind of scrubbed back and forth to see like the Waterman Street, which is the street that Brown's on. So it's not super interesting, but you can see kind of the weather is kind of manipulated. The idea is that we try to make it look a little bit more like what that person saw when they were there. So we ran this 2-week study from people from the local population. So we didn't use students this time. We just found people in the local area. And we wanted to see what happened when we had them track their location, and then when they came in, we could show them these rewinds. Like, what would they remember? Did they feel like it was actually their memories? Did they want to keep these? Those were the questions that we had. So kind of some of the results we had so far is were kind of interesting. So for whether or not people could remember a location in the past or sort of memory, we actually turns out there's a couple of types of ways people remember things. One was, I guess it's called semantic memory. They remember this like place, or they remember the street, they remember this building. So they're like, this is something I remember specifically. The other is episodic memory. They actually remember that specific instance. Like, I was there that time, and it felt really good, and I had friends. And it kind of depends on what kind of people they're with and the experience. But it turns out if the rewinds that they saw had these kind of visual cues, like street signs or buildings in it, then they would be way more likely to remember that building or the specific location. But if they were with other people, or if there was something that was more kind of emotional, they would remember that kind of episode a little bit better. So that was kind of interesting. We also asked people, did you want these memories? Is this something you want to keep? And people only wanted to keep memories basically for 2 reasons. If they were aesthetically pleasing, like if they saw the rewind, they looked really good. So they had a pretty high bar for that. But if it was in that case, then they'd want to keep them. Or if they elicited specific positive emotions. So from an episodic memory, if they remembered I saw my grandma, she baked me a cake that day, and that's how the path I took to get to her place, then they'd want to keep that, the rewind. That was interesting. The last kind of interesting finding we had is that this is especially true when people were driving, is a lot of times people would only remember the beginning and end of a trip. So they get into the car, and I guess they have to look around a bit, and then the middle of the trip is completely disappeared from their memory. Anything we show them in the middle of the trip is they don't remember at all. And in the end, they often remember it a little bit, not as much as the beginning. But the 2 endpoints were kind of the things that they captured in memory. So that was really interesting. And we actually noticed an even greater effect for people that said they used GPS a lot. The middle of the trip was almost always gone. For people that didn't use GPS, sometimes they remember some of it. But either way, it was always the beginning and the end that was the most important. So I thought it was kind of cool. It was hard to do this kind of study without location data and this kind of free data that we had. And so these are the projects I want to talk about. Anyone have questions about Rewind? Yeah.
So you showed how you can simulate weather conditions and times of the year, but that started with a very neutral image where the sky was clear and it seemed it was summer or something. But Google Street View images are not always like that. So what do you do if there's already rain in the image, or snow, or something?
Yeah. So I think the computer vision part of it is not super sophisticated. So I think Google images, Google Street View images in general are like sort of clear days. I think most of them are. There are some that are not, and I think in that case it doesn't do much. Like it adds rain and it just looks a little bit more rainy, so it's almost like a null effect, I noticed. So it's not super exciting. But there should be maybe a way to like remove the rain, and I think that's something we haven't done. So we were trying to come up with a technique that works really fast on like hundreds of images within like seconds. And usually the current state-of-the-art computer vision techniques take like minutes for a single image. So it's, we're trying to kind of do a trade-off between kind of efficiency and realism.
Thanks.
Yep.
It seems like what you're really doing here is taking a low fidelity memory probe. And I'm wondering if you have compared that with really good images that somebody took with their own video.
Yeah.
You have very high fidelity, you have people they know, you have the right time of year, it would be something that literally was part of their memory traces. But yours is very, very low fidelity, and I'm wondering how close you can get to
Right.
a good memory trace.
Yeah, and we're thinking of that as the next study. Like, there used to be projects called like a sense cam, where someone would wear the camera for a long period of time. So how does that actually compare with that? I think that's actually a great question. We don't know that yet. Thanks for the questions. I want to kind of talk a little bit about kind of how this maps to the principles I talked about earlier. So remember I had some ideas about, hey, we want to use personalized products, we want to build personalized products from just this behavioral data. And we've done that, I think, in a few ways, right? So we've got these things that kind of change how we do things. But on the other hand, sometimes I feel like this is actually not good enough. Because what I've shown you is that some of these systems have the potential to change the way we do things, but we actually haven't gotten these systems out there and having people, had the people use them on their own that much. So besides Webgazer, a lot of these products are kind of more things that we've been doing in the lab. And so we're kind of working right now on what I call a kind of post-paper era. So we've been either published the paper or we've submitted the paper, and now we're like, what can we do now, and actually keep working on these systems. So I spent a lot of time thinking about that, and I think there's a kind of a gap between our systems and what makes them into desirable products. There's kind of a little bit of work to do. I think it requires substantial effort into doing that. So we want to keep iterating on the system. So I want to talk about a few ways in which we're doing exactly that. For Webgazer, I mentioned, we've got this data set. Accuracy, I think, is the most important thing for Webgazer. We've got this data set where we actually have the video interactions, eye tracker, the captured screen recording, so a whole bunch of rich data, multiple sources of ground truth, and we actually want to optimize the accuracy over a long period of time. I think once you have the accuracy up, then actually people can be using it for things that are maybe at word level, or at least maybe like, multiple, within 1 or 2 words. I think that would be really exciting. For Webgazer, that's the piece we're working on right now. For sleep culture, one of the problems is the idea that, hey, maybe people that are opting into the study are a little bit different, or we just have it for one experiment, there's maybe some kind of bias. So the idea is now we're actually running a 10-year study. It's a little bit ambitious because it's over a longer period of time than most grants, but we're going to keep it up and running. And the idea is this, it's actually, you don't actually have to do it for 10 years. At any point you can stop, of course, but we'll give you recommendations over time, and the idea is you can just get a lifetime of sleep improvement. So you can constantly get new recommendations and slowly optimize your own sleep over a long period of time. Because once we fix something, then we can give you recommendations for something else. So just continuously gives you recommendations for sleep. So you can sign up for this study, and we actually have some apps that you can get and start getting recommendations pretty soon. I think we're going to kick it off this summer. So that's sleep culture. For Rewind, for your own memories, we're deploying a self-service application, so we want to just have like a standalone thing, and hopefully try to figure out like what is it that makes it so that you actually want to use it and capture your memories from it and put in your location data. So something that's kind of client side, I think, is important, where you're not uploading all your location data to a server, and something that generates useful memories. And the last one is Drafty, which I mentioned is we're trying to host additional data sets. I think it's beyond the computer science professor data set, which is used. We also are creating data sets of scholarships and fellowships that people apply for, and making it a platform so anyone can host their own data sets. So I think that's going to be really cool, the next thing we're doing there. So with that, I want to thank you all for coming, and also thank all these students that worked on these projects. And I'll be happy to take any remaining questions. Yeah?
Are there any systems that use like Webgazer for like trying to scroll on a web page?
to use our ItoSchool. Yeah, I did see some people did send demos of that. I think that's actually the easiest thing to do, right? Like you just use your ItoSchool. The problem is like if you just have a website and all you do is scroll, it's not that exciting. So it's a feature that you can add to a website, but it's sometimes not worth it for people to like agree to let you do eye tracking just to scroll on a page with their eyes. But I think actually like quite a few students have done it as their project, and like it's like usually a good like starter thing to do. Yeah.
Did you face any trouble with the eye color? Like,
Right. So there are actually some features where eye tracking is a lot harder for than others. The eye color actually, if the only times when we have difficulty is when the pupil is basically the same color as the iris. So some people have that. Most people actually have a brown iris, so it's still okay. But if it's exactly the same, then it doesn't work as well. It still works a little bit because the iris moves a little bit too, right? So, but it doesn't work quite as well. There are some features like glasses in which like the reflection in the glasses make it problematic since it's not infrared. You actually get a visible light reflection in your glasses, which is kind of a bummer. But I think we've solved the glasses problem. Like it works almost in all cases with people with glasses now. It actually depends a lot on who's working on it. So whenever there's a student working on it that wears glasses, then usually the glasses problem is resolved slowly. Or we had the first problem we had is Alexandra has eyes that are a little bit deeper into her face, so there's shadows in her eyes, so that actually caused problems in the beginning, and then that was fixed pretty quickly. And now the problem we have is when people have a lot of beards, or I don't know if that's the right term, singular beard, if they have a lot of hair on their beard, I guess, then it doesn't work because it doesn't capture doesn't know where the eye is that well, and I think it's a problem with training data. There hasn't been much training data of people with beards in the data set that we have, so I think maybe, yeah, we need to have a PhD student that has a beard work on this project. Maybe that's the solution.
Maybe someone can grow one for science.
Yeah. Or we'll buy like a beard wig or whatever it's called. Yeah.
You mentioned in one of the slides that you personalized your system using the behavioral metrics.
Mm-hmm.
Have you found any consistency between different metrics among different subjects?
For which systems?
Yeah. At least like a slide with the personal metrics, and then you mentioned correlations between them.
For sleep?
Yeah,
oh, yeah.
Sleep, yeah.
Yeah, so everyone is really different, and the idea is like we actually try to figure out what things are correlated for you specifically. So we did find like a lot of people are very different. Like some people are more sensitive to noise than others. So noise affects someone's sleep quality much more than another person. So we did find a lot of this data, and so the idea is if noise is a factor that affects your sleep, then we give you recommendations based on noise to try to reduce that. So that's part of the system. That's like part of the automated system that we already have. It identifies high correlations.
So you haven't done any data mining for those metrics, but you just use them in a deterministic way to provide the feedback.
Exactly, yeah. So I guess for us, we're not doing like sleep research. We don't care as much like in general for the entire population what affects sleep and what are some things. We just want to say like for each person, can we improve their sleep? Because if one person says like they felt they improved their sleep based on this change, then that's good. And if we can scale that up to each person.
All right, let's
All right.
thank Jeff for his fantastic talk.
Thank you.